All right, today we're diving into a story that's got everything. A massive AI breakthrough, absolutely staggering numbers, autonomous robots, and of course, a fierce scientific debate that erupted right after. We're talking about a project from Google DeepMind called GNoME, an AI that was designed to completely revolutionize how we discover the very materials that build our modern world. So, why is finding new materials such a big deal anyway? Well, think about it. For centuries, the process of discovering the stuff that makes better batteries, faster computers, or stronger buildings has been just painfully slow and super expensive. It's always been a mix of intuition, a whole lot of trial and error, and yeah, a little bit of luck. And this timeline, it really paints a picture of what you could call the artisanal era of materials science. I mean, going from a cool idea in your head to a product people can actually use can take up to 20 years and cost as much as $100 million. That's a huge bottleneck for any kind of progress. So what if you could just shatter that timeline? What if you could accelerate things? Well, that's exactly the promise of AI. In late 2023, Google DeepMind unveiled GNoME. And their goal was insane, to basically take an 800-year leap forward in our knowledge of materials. I mean, the numbers here are just mind-boggling. GNoME predicted 2.2 million new crystal structures. To give you a sense of scale, DeepMind said that's like cramming almost 800 years of human research into a single project. Just wow. Okay, but millions of predictions are useless if the materials are just fantasy, right? If they can't actually exist in the real world. So the next step was crucial. GNoME filtered all of those predictions for stability, and it landed on about 380,000 really promising candidates. Let's put that in perspective. Before this, all of human history had discovered about 48,000 stable materials. This one project expanded our entire library of known materials by nearly 10 times. So you've got to be asking, how does an AI even do this? How do you get from lines of code to a physical thing you could, hold in your hand? And maybe even more importantly, how do you prove it's real? Well, the secret sauce here is this really elegant process they call an active learning flywheel. So here's how it works. Step 1, the AI just goes wild, predicting millions of structures. Step 2, it filters them down to the ones that look the most stable. Step 3, it double-checks those with really powerful computer simulations. And here's the really brilliant part. Step 4, every single result, whether it was a success or a failure, gets fed right back into the AI to help it learn. This loop, this flywheel, is what took its hit rate from a measly 10% to an incredible 80%. But, a computer prediction is still just a prediction. To really prove their point, DeepMind teamed up with an autonomous lab at Berkeley called the A Lab. Basically, think of it like a self-driving car, but for chemistry. And get this, in just 17 days, these robots tried to make 58 of GNoME's predictions and successfully cooked up 41 of them. A human researcher, that would have taken them years. Okay, so this sounds amazing, right? A total revolution in science. Well, not so fast. Almost as soon as the news dropped, the scientific community started poking holes in it, asking a really fundamental question. Are these discoveries actually new? The heart of the debate comes down to this tricky concept called compositional disorder. So here's an analogy. Imagine GNoME is predicting a perfect, beautifully layered cake, with every ingredient in exactly the right place. But anyone who's ever baked knows, especially when you crank up the heat, things get messy. Ingredients mix together. That's kind of what happens in real-world crystals. Atoms can get jumbled up and share the same spot. And the critics said GNoME's perfect models were totally missing this messy reality. And the criticism wasn't gentle either. One team, led by Robert Palgrave, put it bluntly. They argued that the A-Lab's own AI totally misread the results, claiming its interpretation of the data was, and I'm quoting here, worse than even a novice human would achieve. Ouch. They said the AI was seeing these perfect, new, ordered structures when a human expert would have immediately recognized them as well-known, just messy, disordered materials. So let's be clear about what the debate was really about. It wasn't about whether the robots mixed the powders correctly. It was about whether the AI understood what it had created. Basically, the critics were saying, hey, not only are your robots and new materials just messed up versions of old ones, but a lot of your 2.2 million other predictions are probably just weird, chemically unlikely variations of stuff we already know. So this whole debate really forces us to step back and ask a big question. If GNoME isn't some magical oracle that just hands us perfect new materials, then what is its real contribution?
And this, I think, really gets to the heart of the matter. Genome isn't an oracle providing the final answer. It's more of a hypothesis engine. It didn't give us the treasure, it gave us a massive treasure map with hundreds of thousands of X marks the spot locations for scientists to start digging. It's not supposed to finish the race. Its job is to get rid of most of the wrong paths before we even take a step.
And why does that matter so much? Because the stakes here are absolutely massive. I mean, we're talking about the search for things like safer cobalt-free batteries. Genome pointed to over 500 possibilities. Or brand new superconductors. Or revolutionary 2D materials like graphene. Genome found over 52,000 of those. It gives researchers a gigantic head start in the hunt for these world-changing technologies. And look, this isn't just theory. The rubber is already hitting the road. While those critiques are super important to the scientific process, the proof is starting to pile up. As of today, other labs, totally independent of Google, have already successfully created and verified more than 700 of Genome's predictions. The engine is working. But a breakthrough this huge doesn't just solve old problems, it creates brand new ones. It starts to shake the very foundations of how we do science and even how we define discovery. Take patents, for instance. This is a huge, thorny issue. If Genome spits out the recipe for a trillion-dollar battery material, who gets to patent it? The people who wrote the code? The company that owns the servers? Right now, US law says an AI can't be listed as an inventor. So, does nobody own it? It's a massive legal gray area that could actually slow everything down. So in the end, Genome is a landmark moment. And maybe not because it was perfect. It wasn't. It's a landmark because it forced a really important conversation. It proved without a doubt that AI can change the scale of scientific discovery. But it also showed us that just having mountains of data isn't enough. You still need human wisdom and critique to make sense of it all. What Genome did was open up this vast, new, uncharted frontier. And the challenge now, for everyone, scientists, lawyers, all of us, is to figure out how to draw the map.